In the space of science and colossal, lean toward pieces of information, the subject of what existed from the beginning to the tremendous impact has blended conversations and enraptured characters for quite a while. This Goliath question doesn't just test how we could disentangle the universe. It challenges the genuine farthest goals of human knowledge. Imagine standing at the edge of existence, reviewing the vast shadowing, and considering what lay there before our universe was conceived. The event of the Big Bang signified the beginning of history, space, and what we know. However, there was a moment preceding time itself. Was there, in the end, a state of nothingness, a quiet before the roaring gathering began? And if this is true, was it truly nothingness, or perhaps something fundamentally unsettling existed before time itself? As we delve further into this question, science takes us on a journey beyond the universe's starting point into realms of thought that challenge our imagination. Physicist Brian Cox, known for his focus on the wonders of the universe, proposes that something astonishing might have existed before the Big Bang. He challenges us to rethink our understanding of the natural world and existence. In this evaluation, we'll unravel the science, theories, and astounding secrets that could explain what existed before everything. We'll explore concepts like eternal inflation, quantum fluctuations, dark energy, and even the multiverse. The answers we've uncovered may astonish you, yet they could also open new understandings of our place in the cosmos. Prepare to dive deep into a world beyond imagination and science, where the darkness still lingers in the shadows, leaving experts stunned and sometimes even unsettled. Let's dissect what existed before the Big Bang and why these theories challenge everything we thought we knew. To appreciate what might have existed before the Big Bang, we first need to understand what the Big Bang truly was. As astrophysicists describe it, the Big Bang was the moment when the universe became extraordinarily hot and dense, expanding rapidly to trigger the formation of all matter, energy, and fundamental forces. When we observe the night sky, we see evidence of this hot beginning, with galaxies fanning out from a central point. But what caused this to happen? Was there a time before this dense, hot start? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or quiet. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and free, essentially like an expanding vacuum. However, this vacuum wasn't completely empty. It contained an enormous amount of energy that powered the rapid expansion of space itself. This expansion, known as inflation, happened so quickly that it effectively set the stage for everything that followed. In a fraction of a second, space stretched at astonishing rates until the inflation slowed, and the energy transformed into matter, particles, and the forces we observe today. What powered the inflation? What was the nature of this energy? Why did it emerge seemingly out of nowhere to birth the universe? And why did it stop? Scientists theorize that this process of inflation could have created patches of the universe, each experiencing its own Big Bang. Imagine a surface expanding infinitely with countless tiny bubbles forming, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests there could be countless Big Bangs and an infinite number of universes. Our universe is just one of many in this grand cosmic ensemble. This concept reshapes our understanding of the universe itself and raises profound questions. What else is out there? If the multiverse exists, what are its limits? And does it have a beginning or end? Is nothingness truly possible? The idea of nothingness before the Big Bang is at best theoretical. Even if you strip away all energy, particles, and radiation from the universe, it would not truly be empty. The universe is filled with dark matter, dark energy, quantum fields, and other forces that we have yet to fully understand. Even in its emptiest state, the universe still holds something. Consider the concept of zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still appear and disappear, creating a faint hum of activity even in what should be a void. This reality astonishes researchers, as it suggests that absolute nothingness might be impossible within our current understanding of physics. Imagine creating a space where there is literally nothing. No particles, no radiation, no energy. Even then, quantum fields and fundamental constants would still exist, meaning the nothingness would have properties. This challenges our basic understanding of voids and suggests that even before the Big Bang, there was something. Eternal inflation and the fractal universe. One of the most fascinating theories in modern cosmology is the idea of eternal inflation. If inflation could create our universe, it's possible that it could continue indefinitely, creating countless other universes. Brian Cox describes an enormous, inflationary multiverse where universes are continuously born and evolve. Each Big Bang could be seen as a spark igniting a new universe, while inflation continues elsewhere, forming infinite other universes. This process could, in theory, go on forever. It suggests a fractal-like multiverse, where every new universe may, in turn, spawn its own Big Bang. Each universe exists as a separate, independent space, unaffected by the others. For scientists, this theory is both thrilling and unsettling, as it implies a relentless multiverse with no clear beginning or end. Imagine our universe as just one small part of a vast cosmic mosaic, a perpetually creating system of universes. If this is the true nature of reality, then there is no before or after, only an eternal pattern of universes forming. Energy suggests that a beast, secret of power, might have existed in some structure prior to the huge explosion. A few speculations propose that dark energy, in a much stronger state, might have controlled the inflationary stage, causing quick expansion. The presence of dark energy proposes that, whether our universe was exhausted of all matter and radiation, this power would continue to foster the external layer of spacetime. This idea prompts an unsettling inquiry. If dark energy was present before the huge explosion, might it have ultimately formed the conditions that led to the birth of our universe? Could dark energy be the silent architect of inflation, or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy not merely as a force shaping our universe, but as a key that could unlock the secrets of the multiverse itself. Another speculation, cyclic cosmology, offers an alternative to the huge explosion as a definitive beginning. This hypothesis proposes that the universe goes through vast patterns of birth, death, and renewal. In this model, the huge explosion is not a one-time event, but rather part of an eternal cycle where universes form independently and then restore in another cycle. This hypothesis suggests that our universe could have been re-established from the remnants of a previous universe. The process of compression and expansion in a cyclic pattern would imply there was never a true beginning, but rather an everlasting series of universes emerging and restoring themselves over and over. Cyclic cosmology raises profound questions. Never a better time than now, as it proposes that time itself could repeat rather than proceed. If this theory is correct, it could mean that what existed before the huge explosion was simply another form of the universe, one that collapsed solely to give birth to our current universe. For scientists, this hypothesis offers a rich solution to the question of extreme beginnings, suggesting that there is no clear starting point. The universe has always existed in some form, transcending our concepts of time and existence. Gravitational waves are another fascinating concept that could shed light on what existed before the huge explosion. These waves, discovered in 2015, are ripples in spacetime caused by incredibly massive objects like black holes or colliding neutron stars. These waves can travel vast distances, carrying information about the events that created them. Could gravitational waves provide insight into the formation of the universe? A few physicists propose that gravitational waves from the time before the huge explosion could offer clues about the state of the universe before inflation began. Gravitational waves from the early universe might leave traces that could help us understand whether the huge explosion was truly the beginning or whether there were cosmic events before that we do not yet appreciate. These waves could be remnants left by events beyond our conventional understanding. Their presence may also imply a greater structure beyond the one we are familiar with. These faint signals could unlock insights that could profoundly impact our perspective, much as we uncovered the huge explosion's origin. Consider the possibility that they reveal the faint hints of a past universe or an event that occurred before the huge explosion. As researchers continue to explore the deep expanses of space, the question lingers: what existed before the huge explosion? With current theories highlighting quantum mechanics, multiverses, and cosmic evolution, it seems we are closer than ever to unraveling the profound secrets of the universe's origins. While the complete answer remains elusive, our understanding of what existed before the huge explosion continues to evolve with each discovery. As we explore these theories, we can also consider how they might fit together to reveal the bigger picture, the true essence of existence itself. Until then, we are left with the mystery driving science in uncharted territories far beyond what we have yet learned. One critical area of research involves the relationship between existence itself and time as we experience it. Time might not have existed in the way we understand it before the huge explosion. Some theories suggest that time, as a concept, began with the huge explosion, making it impossible to trace what came before. This idea challenges our fundamental perception of existence, suggesting that the question of before may not even be relevant when it comes to the universe's origins. Moreover, recent advances in the study of quantum mechanics have sparked groundbreaking ideas about the nature of reality. One particularly intriguing concept is the possibility of a quantum vacuum, a state where, even in the absence of matter, the universe is not truly empty. Rather, it is filled with fluctuating energy fields that can result in particles and forces. These quantum fluctuations could have played a critical role in the formation of the universe, providing the essential conditions for the huge explosion to occur. This raises the question of whether the universe could have emerged from a quantum transition, or alternatively, if it was somehow triggered by these fluctuations. Another fascinating aspect of pre-huge explosion theory revolves around the idea of cosmic recycling. In cyclic cosmology, the universe undergoes a perpetual series of expansions and contractions. After each huge explosion, the universe would eventually contract again into a singularity before expanding once more. This recurring process could mean that the current state of the universe is merely the latest cycle in an eternal series of cosmic births and deaths. Some researchers suggest that each cycle could lead to slightly different outcomes, with the current structure of the universe shaped by the conditions of the previous cycle. This idea challenges the notion of a definitive beginning, suggesting instead that the universe is in a constant state of renewal. The possibility of additional dimensions also adds another layer of complexity to our understanding of what preceded the huge explosion. String theory, for example, suggests the existence of extra dimensions beyond the familiar 3 dimensions of space and 1 dimension of time. These additional dimensions could provide an entirely new framework for understanding the universe's origins. These additional dimensions might hold the answers to questions about the universe's origins and its underlying structure. If such dimensions exist, they could explain phenomena that are currently beyond our comprehension, such as the forces driving inflation or the mechanisms behind the initial conditions of the huge explosion. Another promising area of investigation involves quantum gravity, which seeks to merge quantum mechanics with general relativity. Understanding how gravity behaves at the quantum level could unlock insights into the earliest moments of the universe, or even what came before. Theories like loop quantum gravity suggest that space-time itself might be quantized, existing in discrete units rather than a continuous flow. This perspective could imply that the universe's beginning wasn't a singularity, but a transition from one state of existence to another. Such transitions might occur cyclically or as part of a larger, multidimensional framework. The multiverse hypothesis also presents a radical view of existence. It proposes that our universe is just one of countless others, each governed by its own physical laws and constants. In this scenario, the huge explosion might have been a localized event within a much broader multiverse. Other universes could be spawning, existing, and collapsing in ways that parallel, interact with, or remain entirely separate from ours. This perspective raises profound questions. Could events in another universe have triggered the conditions for our own universe's birth? Might gravitational waves, dark energy, or even quantum fluctuations hold clues to interactions between these universes? If so, understanding the multiverse might lead to a paradigm shift in how we perceive reality. These ideas also challenge our understanding of time. If time is not linear and unidirectional, as we experience it, but instead cyclic, multidimensional, or emergent, it reshapes the narrative of beginnings and endings. Time could be a construct that arose alongside the universe, rendering questions about before the huge explosion meaningless within our current framework of understanding. Further complicating the picture is the role of entropy, the measure of disorder in a system. According to the second law of thermodynamics, entropy always increases in a closed system. However, some theories suggest that entropy might reset or behave differently under extreme conditions, such as during a cosmic contraction preceding a new cycle of expansion. If this is true, it could provide a mechanism for cyclic universes and challenge our assumptions about the arrow of time. Each of these theories, whether focused on dark energy, quantum mechanics, gravitational waves, or multidimensional structures, adds a layer of complexity and depth to our quest for understanding the universe's origins. They push the boundaries of what we know and challenge us to rethink fundamental concepts like time, space, and existence. While many questions remain unanswered, the search itself is a testament to humanity's relentless curiosity. With each discovery, we take another step closer to unraveling the mysteries of the universe, not only to understand where we come from, but also to grasp the true nature of reality and our place within it. As science continues to advance, the tools at our disposal, such as powerful telescopes, particle accelerators, and advanced computational models, will play a critical role in testing these theories. Observing the faint echoes of the early universe, identifying traces of gravitational waves, and uncovering evidence of additional dimensions could transform our understanding in ways we can scarcely imagine today. Ultimately, the question of what existed before the huge explosion might not have a simple answer. It could lead us to entirely new paradigms, revealing a universe, or multiverse, that is far more intricate, vast, and awe-inspiring than we ever thought possible. The journey to uncover these truths is as infinite as the cosmos itself, urging us to keep exploring, questioning, and reaching for the stars.